Alright, so in this video I want to go over some practice with L'Hopital's rule, and I'm specifically just going to focus on why we have to only use L'Hopital's rule when we have an indeterminate form. And to get this across to you, I'm just going to do one example to show you the difference between when we can use L'Hopital's rule and when we can't. So remember, the way the rule is set up is that you can use L'Hopital's rule anytime you have an indeterminate form, and the two I like to focus on are 0 over 0 or infinity over infinity. So if you have one of these cases that arises when you are doing substitution, you end up with infinity over infinity or 0 over 0, then in order to get an answer to the limit, you can use L'Hopital's rule by taking the derivative of the numerator and dividing it by the derivative of the denominator, and then evaluating the limit that way. So let's try an example where this happens. So to illustrate when we can and can't use L'Hopital's rule, let's evaluate a limit of the same function but just at two different values. So let's say we want to evaluate the limit as x approaches 2 of x squared minus 4 divided by 6 minus 3x, and we'll do the limit as x approaches 0 of the same thing, x squared minus 4 over 6 minus 3x. So remember, when we do the limit, our first step is to just substitute in the value and see what happens. So if I substitute in 2 for the first example, I'm getting 2 squared minus 4 over 6 minus 3 times 2. So I'm getting 4 minus 4 over 6 minus 6. Then this is 0 over 0. So I do have an indeterminate form here. I have 0 over 0. I'm not getting a solution right away to the limit using substitution, so I'm going to need to use our other method, and that method is L'Hopital's rule. So I take the derivative of the numerator and divide it by the derivative of the denominator, still with that limit. So now I have the limit as x approaches 2 of 2x minus 0 for the derivative of my numerator, and then 0 minus 3 for the derivative of my denominator. If we simplify that up, I'm really looking at the limit as x approaches 2 of 2x over negative 3. So I've done L'Hopital's rule, and now I have something new that I can find this limit of. I substitute in 2, I'm getting 2 times 2 divided by negative 3, so I'm getting negative 4/3, and that's the solution for my limit. So I substitute in the value, I got an indeterminate form. That let me know I could use L'Hopital's rule. I took the derivative of both the numerator and the denominator, and I evaluated the limit again. And when I did it, substitution worked after I took those derivatives with L'Hopital's rule, and I got negative 4/3 as my answer. Okay, let's repeat this process for the other limit we were asked to solve. So here, it's the same function, we're just doing the limit as x approaches 0. So here, remember, my first step is to plug in the value, substitute in 0. So I'm getting 0 squared minus 4 all over 6 minus 3 times 0. Then when I simplify this, I'm getting negative 4 over 6, which is negative 2/3. And so actually, this is just the solution to my limit. We didn't need L'Hopital's rule here because we could just evaluate the limit using substitution. But let's say we didn't realize this and we were just really excited, we saw a fraction, we thought we were supposed to use L'Hopital's, and we just didn't check for an indeterminate form first. Let's see what would happen if we use L'Hopital's anyway. Why can't I just use it on everything? So if I took the derivative of both the numerator and the denominator here and tried to evaluate the limit, we know this already from the previous example, so I'm really looking at the limit as x approaches 0 of 2x over negative 3. And remember, I'm telling you we're not supposed to do this, I'm just showing you why. So here we'd substitute in 0 once we incorrectly applied L'Hopital's rule, and I'd get 2 times 0 over negative 3, which is just 0, since anything times 0 is 0. So I'm getting 0 as my solution, which isn't right because the actual answer is negative 2/3. So this didn't work out to use L'Hopital's rule, we couldn't just do it anyway because we ended up with the wrong answer. So this is just one illustration of why you really need to check that you do have an indeterminate form first, instead of just jumping right into using L'Hopital's rule. Okay, hopefully that explained a little bit the importance of checking for an indeterminate form before you use L'Hopital's rule, and just gave you a little bit of practice with evaluating limits. Thanks so much for watching, and I will talk to you in the next one.